This is the Building Automation Monthly Podcast with Phil Zito, episode 73. Hey folks, Phil Zito here, and welcome to episode 73 of the Building Automation Monthly Podcast. And in this episode, I'm going to be taking you through how to wrangle in out-of-control alarming. Everything I cover in today's podcast episode can be found at buildingautomationmonthly.com/73. Once again, that is buildingautomationmonthly.com/73. All right, let's talk about this episode's tech tip. So the tip I want to take you through today is a little trick I learned when I was installing hundreds of VAV boxes at an Intel fabrication plant. And as you may or may not know, when you go and start to daisy chain 24 volts AC from a 24 volt AC transformer, and you start to go and connect this to controllers, you'll start to see a voltage drop. Now, normally a 24 volt AC transformer with no load on it will be around 30 volts. As you start to get closer to a fully loaded transformer, you'll start to see the voltage decrease. And one of the ways, rather than trying to calculate VA and watts and figure out if your controllers are actually drawing enough or too much, or those kind of questions that you have around voltage, one of the tricks I've found is to go and actually just meter the voltage coming off your transformer as you're adding these controllers. And typically, if you're around 26 volts on VAV boxes without their actuators driving, then you should be pretty good, because you got to factor in that when the actuators actually start driving, that's going to draw some wattage across that transformer. That's going to drop your voltage. Now, why does it drop the voltage? Well, it drops the voltage because as you are introducing resistance, less voltage can travel across the wire. That's kind of Ohm's law there, right? The resistance impedes the voltage traveling across the wire. So that is my tip for this episode, is simply to go and look at your voltage, meter your voltage. And the cool thing about AC is it's polarity insensitive. So whether you put your leads on the common or hot, or you get them mixed up, doesn't really matter. It's not like DC where polarity matters. But you can simply go and put your leads from your multimeter on the wire at your longest controller run, see what the voltage drop is. You'd probably be getting around 26 volts. And that means when all the actuators fire up, you should be sitting around 24 volts. You should have enough voltage to get those controllers going. Now, if you want to be even safer, you can aim for like 27 volts. But usually these actuators aren't drawing a ton of voltage. So that's my trick for you right there, is simply to go and look at the voltage, understanding that normally you'll have 30 volts. And if you don't believe me on that, go get a 24 volt transformer, test it out, go power it up, and you'll see around 30 volts coming off of it. And then when you actually start to introduce load, you'll see that voltage drop because you're introducing resistance, which is impeding the voltage traveling across the wire. So that is your tech tip. Now, let's talk about today's topic, which is wrangling in out-of-control alarming. You know, there is this problem in the building automation world, and not a lot of folks talk about it. You know, everyone is like, oh, let's get analytics, let's get fault detection, let's set up trends, let's retro commission buildings. Yet, amongst all this talk of all those really cool things, folks aren't talking about the elephant in the room, which is that you're supposed to be able to know when things are starting to fail. You're supposed to see the signs. But yet, because of the way that we put in alarming, because of the way that alarming is set up on jobs, we are not aware of what's going on. We're having failures that sometimes stay hidden for years because they simply get mixed. And I had this point really driven home to me when I was at this really big life sciences customer. and it was one of the biggest ones in the world. And I remember this like the other day. We're standing in the control room, and I mean, they had these massive screens, and they had a really, really well trained people. I mean, they had folks on their facilities team who were PhD folks. I mean, these were some good folks because when you understand life sciences or any of those places, I've worked in a lot of life sciences, I've worked in a lot of industrial and fabrication plants. Any of those areas, the tolerance for temperature and humidity swings is so tight because any minute environmental change could affect their research, could affect their testing. And so they try to eliminate those environmental changes so that they have a steady, stable environment and they can go and run these tests. Because what I didn't know, but I found out talking to these folks, is that if one of these tests, and these tests run for like 6 months, one of them fails, there are literally millions upon millions of dollars that are lost from one of these tests failing. So imagine my surprise, and imagine their surprise, when they find out that one of their chillers in their central plant had been down for 3 hours. 3 hours it had been down. Now, I don't know how they didn't notice that. Maybe it was running a lead lag scenario and they just didn't realize it. But suffice to say, when they started to get drifts in their temperature, and this fortunately was in the late fall, so it took a little bit, but they started to get drifts in their temperatures, and then they're like, wonder what's going on. And they started to dig a little and started to dig a little more, and then they figured out that a chiller was offline. And when that happens at a big place like this, everyone goes into disaster mode, and it's like you might as well just end your day because you're not going to finish your service call. You're going to just be sitting there watching them do stuff. So went on to a different job site. But I later came back and I talked to the folks and was like, well, what happened? Apparently, they had no alarm segmentation strategy. And so they were getting filter alarms, low temp alarms, faulty switches. You've heard of flapping switches before. If you've been in the BAS world for any amount of time, you've probably heard the term flapping switches. It's where a contact doesn't fully close, and so it kind of opens and closes, opens and closes. This is notorious on safety contacts, on fan contacts. It's notorious for these things, and you have to go and adjust their sensitivity. It's part of just a maintenance process. Well, anyways, all the alarms were exactly the same. They were all exactly the same priority. And because of this, these critical alarms, these things that could literally take down the entire campus, they were being intermixed with things like filter alarms and condensate drip pan alarms. And it was like, wow. And they had 50,000 unacknowledged alarms. They were telling me that on an average week they would get, tens of thousands of alarms. And they, at the end of the week, they would just go and Control A to highlight them all and just press delete. They would just delete them all. That's how they managed alarms. And the sad reality is this is one of the, what I would consider leading edge as far as BAS goes, as far as maturity of facility teams goes. So, if they are leading edge, then what chance do the rest of us have? How can the rest of us go about creating a facility team, creating a BAS installation or service that is going and essentially on top of things, that's going and staying on top of things and addressing issues and not getting dragged into this vicious cycle of unplanned failures and unplanned maintenance that just overwhelms you so much that you can never do preventative maintenance? Because that is kind of the nightmare of facility management, is if you get into this death spiral where you can't keep up with the maintenance faster than the issues are occurring, that's when you start to see these Band-Aid solutions. That's when things really start to fall apart. You find 2x4s, you find holes cut in ductwork, you find valves with the actuators taken off them, and they're just permanently set at like 80%. That's the real world. That's what happens when you have to quick fix stuff. And I think this all could start if this could all rather be rectified, or at least it could be substantially decreased. Maybe I won't go as far as to say that this could all be rectified by this, but you could substantially decrease the occurrence of this kind of vicious, unplanned maintenance cycle by getting on top of alarms, getting proactive with alarms, setting up strategies with alarms. And that is what this episode is all about. Because at the end of the day, you want to avoid what is called alarm fatigue. And alarm fatigue is where you just have so many alarms that just overwhelm you so much that you just simply give up. You disconnect. For anyone who has dealt with a teenage child, I've got a preteen child, and sometimes I feel like I'm talking to a wall. And I'm sure from her perspective, she's probably just disconnecting, just stopping listening, because I tell her the same thing so many times. And that's kind of what alarms are like for a lot of BAS professionals. You just see so many of them. They're all ultra high priority to the point where nothing's a high priority. So what causes out of control alarms? How do we get to this point where you have this building automation system where the alarms just never end? I mean, after all, we go through these plan processes, we go through these design processes, we go through all of these checks and steps to make sure that we're not at this point. Yet so many projects, I would argue near 99% of them, end up in the situation where all the alarms, if they even exist, are set to the same priority, they route to the same person, and no one can tell what's important and what's not important. The reason that we end up at this point, I've narrowed it down to 3 things. And those 3 things are bad specifications, no point standards, and no clear alarm segmentation strategy. So bad specifications. What do I mean by that? You've all probably seen it, right? You've read that specification where it says point shall be alarmed, or system shall be alarmed, or upon failure, system shall alarm. And it's like, okay, that's great. But what does that mean? What are the conditions? Now, you will see some specifications where they'll say zone temperature 72 degrees, set point adjustable. Shall alarm on high temp if set point is exceeded by 4 degrees for more than 15 minutes. And then you should see shall alarm on low temp if temperature is below set point by 4 degrees for 15 minutes. Both adjustable, the threshold as well as the time. Now, you may see that in a specification. It's 50-50 if you're going to see that. But even that doesn't really help now, does it? Because is a filter switch the same priority as a VAV box? Is a VAV box that serves the data closet more important than a VAV box that serves maybe an open air auditorium? You have to look at the context, and that, unfortunately, is something that a lot of specifications, they're just not very good at. They're not very good at looking at the context of the alarms in which they're asking you to implement. Which brings us to our next point. There are very rarely any point standards. Now, what do I mean by this? Well, as you may or may not know, depending on how long you've been listening to me, I'm kinda anal about standards. I preach this like it's the gospel. I'm like, you must embrace standards. You need to use standards. And I could, and most likely will, do a whole podcast episode just on standards. But the reality is that as much fun as it is to place the blame on one person and say it's the design engineer, if they did a good design, then we wouldn't be in this problem. Well, is it? Is it really their fault? I mean, where do they get the standards, the settings, the understanding of what should be alarmed and what should not? I mean, sure, they lean on their own expertise and experience, and they gain that experience by going through tons of jobs. But what role does the owner have in this? Does the owner know that that building is more important than this building, or that that system is more important than this system? I mean, they should, right? They're operating the facilities. Now, granted, I realize there are owners that are completely disconnected from their buildings. So we're not talking about that two-story commercial office space, which is just built to be rent out and run to the ground. And, it's like a rental car. You're just going to try to get people in there, and you just don't really care as long as the air stays on. We're talking about kind of more high-end buildings, hospitals, university campuses, large corporate campuses, things like that, things where the folks are invested in the building. And those kind of folks, I'm not going to let them off the hook. They should have standards. They should know what systems they want to be more important than the others. Like their central plant, they should tell the engineer, my central plant alarms should always be more important than a VAV box alarm. And my air handler alarms should be more important than a VAV box alarm. They need to sit down with the design engineer, and I'm telling you, I mean, everyone hears the word standards and they picture this like 10-day process where everyone's like in a room and you're just spinning the wheel and it's just hard and you're like, oh, standards. But it's not. I'm telling you, and I know this from experience because I've done it countless times, in 30 minutes to an hour, you can create an entire point standard. I mean, there's only so many ways that you're going to go and condition a space. You're going to have air handlers, chillers, boilers, VAV boxes, fan coils, unit ventilators, exhaust fans. I mean, there's only a couple different system types. Now, some of you will be like, whoa, what if they have a recovery wheel? What if they have this? Okay, so maybe there's a couple different points. Maybe you've got a makeup air unit. Maybe you've got 100% outdoor air instead of mixed air. Okay, I get it. So you've got some minor tweaks and changes. But they still have fans, right? They still have discharge air, right? They still have coils on most of them, right? Your VAV boxes still have dampers and airflow sensors, right? So why not manage to the mainstream instead of the exception? Why not go and create standards for that 90% of the points and then deal with those couple points that make no sense, that don't fit a standard? If you do that, and yes, you can, with the right people at the table, do that in about an hour, then you will go and you will create standards that folks can then go and use in their specification. But you gotta take it one step further. And this one step, and you'll notice this in building automation, there's normally the normal, and then there's this like one more step that you can do. And that one step tends to make a huge difference. It's like naming standards, right? You can go and just name everything VAV, AHU. But if you take that one more step and you identify the floor it's on or you identify the building it's on, that makes such a huge difference. Well, it's the same with alarming. And that one step is called alarm segmentation. And this is where you set the priority level associated with your alarms. But sadly, even in facilities that create standards for their points and define thresholds for their alarms, they don't define alarm segmentation. And quite honestly, for a lot of folks, that's because they don't know alarm segmentation exists. They don't even know they can do it. They don't know that they can go in most building automation systems and select a priority level or a criticality level associated with an alarm. You can actually go and determine on most building automation systems where the alarms route based on what kind of alarm they are. But yet, that lies undone, unutilized, and we're in the position we're in. Folks create the alarms but they've got no segmentation. They've got no prioritization. So when one thing looks like 1,000 other things, that one thing just gets ignored. So how do you resolve these issues? How do you solve this problem? I mean, it seems so insurmountable, especially on existing buildings. But what I'm about to tell you will work on new buildings and it will work on existing buildings. No matter where you are in your process, you can apply what I'm about to teach you. Sure, it'll be hard work if it's an existing building. Sure, you're going to have to go and pay some money and make some changes. But I'm telling you, it is so worth it. So how do you do this? How do you address each issue? Well, I go and I flip things around. While I said that it begins at the specification and it ends at the segmentation, when resolving these issues, you want to start at the segmentation and end at the specification. So what do I mean by start at the specification? Start at the segmentation. There we go. That's the right one. So what do I mean by that? What I mean by starting at the segmentation is that you're going to think about what systems are critical. And you're going to look at the building automation system you have. You're going to look at the capability it has for prioritizing alarms and segmenting alarms. And you're going to spend an hour and you're going to go and you're going to figure out what categories you want. Usually it'll break down to maybe 2 or 3 categories. You'll either have like high, medium, and low, which I really don't recommend low, and I'll get to that in a second. Or you'll have something like critical, priority, normal, which is kind of more what I recommend, something like that. And you'll have that, and then you'll go and you'll put your systems in. So what makes a critical alarm? Well, critical would be something that's going to affect the entire building, like a central plant. What would make a priority alarm? That'd be something that's going to affect a set of subsystems, but not the entire plant, not the entire building, like an air handler. And that goes and affects all the VAV boxes downstream, but it doesn't take down the entire building necessarily. And finally, if you have normal, and these are going to be things like individual VAV boxes, exhaust fans. And in all honesty, if you're using this prioritization strategy right, you're probably never going to get to the normal alarms. They're probably just going to get ignored. Because between the critical and priority alarms, you're going to have more than enough things to deal with. And then the cool thing is, if you deal with those, that's going to decrease the amount of overall alarms, because you're not going to have where a critical system then escalates and damages potentially priority and normal systems, like messing up PID loops and things like that. So I said I don't recommend low. Here's why. Whenever I tell you something's a low priority, what do you think when you hear the word low priority? You think it's not important, right? I mean, if my wife comes to me and she's like, "Hey, I need you to do these 4 things," and this 4th thing, it's a really low priority. It's if you get to it in a couple weeks, it's fine. I'm like, okay, what do you think I'm not gonna do? I'm not gonna do that low priority item, right? Because I realize the higher priority items, they are going to have a much greater impact on her being happy with me than the low priority item. So that is why I recommend that you don't use that kind of structure where you call things low. So I know, a little nitpicky, a little nuanced. That's just what I've experienced from my own experience. With that being said, so now you've got this segmentation, right? Well, what do you do now that you have segmentation? Well, you need to put it into the point standard. Now, I'm not going to dive into how to create a point standard, the steps you should take. I've written articles about creating point standards, and definitely, I'm telling you, if you want to take this to the whole next level, pick up my BAS A to Z training program, where I dive into point standards, naming standards, and I actually give you a standards template that you can use to create your own BAS standard. So, I mean, that alone is worth the price of the program. But you could check that out at buildingautomationmonthly.com/BAS. That will also be in the show notes at buildingautomationmonthly.com/73. With that being said, though, I will tell you one thing. When you create a point standard, it is really simple. I mean, you'll have your name of the point, you'll have the type of the point, you'll have whether it's trended, whether it's alarmed, and you'll have whether it's scheduled, and you'll have your alarm thresholds and your trend thresholds. All you need to do is add another tab that says priority level in the alarming section. That's it. Pretty simple, right? And then you go and you hand off this specification, this standard, to the design engineer. And then they reference it in the specification for all future buildings. What this would look like you creating basically like a PDF of sorts. And this PDF would then be either attached to any specifications or referenced in the specification. And this is what would be used to design the building automation system. So as the building automation system gets designed, as it gets installed, this is what would be used. But what if you have an existing building? How can you go about retrofitting this existing building? How can you go about making sure that this existing building is working the way you want it to work and has these alarm standards in place? Well, it's actually really simple. It takes some time, it takes some money, but depending on the control system you have, you suck in the database from the existing installation. You go and you use some sort of point tools, some sort of mass editing tools, and then you just go and you apply your standard onto the existing points. Then you go and you re-download the changed database, and voila, you're done. I know I made it sound simple in like 30 seconds. I'm like, oh, you just do this, this, this. Yes, there is definitely more to it. You definitely have to make some steps and some choices, and you may have to change points around. You may have to go and add on email functionality, especially if you want to use some sort of escalation that emails out alarms to people. But you get the point. It's doable. It's something that once you have the steps in place, the documentation in place, you can go and do it. And it doesn't have to be all done at once. This isn't a all or nothing thing. The fact that you go and you implement this 10% means 10% of those alarms are prioritized now. So you can go and gradually implement this on existing buildings. So there you have it, folks. That is my step-by-step process on how to eliminate alarm fatigue, how to destroy alarm fatigue. If you follow these steps, whether you're an owner, a design engineer, an installer, a salesperson, I'm telling you, you will make massive differences in the buildings that you work with. I mean, it cannot be understated how important it is to have a full operational picture of what is going on in your facilities. And with a proper alarming strategy, you will provide that to your customers. They will notice the difference, especially if they've worked at other facilities in the past that do not have these capabilities. So I really encourage you to take this to heart, make it part of your design process, make it part of your engineering process, make it part of your sales process. You will never regret implementing this. And with that, remember, everything I discussed today can be found at buildingautomationmonthly.com/73. Once again, that is buildingautomationmonthly.com/73. And can you do me a favor? If you found this podcast to be immensely helpful, to be really giving you step-by-step processes and exposing you to what you need to know in the world of building automation, I would love it. I would be so thankful if you would just go copy the link to this podcast episode and share it on your favorite social media platform. Maybe that's Facebook, maybe that's Twitter, maybe that's LinkedIn. It would mean so much to me if you would share this and help get this podcast in the earbuds of other folks who want to be the best at building automation systems that they can be. And until next time, remember, keep working hard, Keep pushing. You can and will get better at building automation systems. It's up to you, and I know you can do it. And I'll talk to you in the next podcast. Take care.